This is a presentation on how to develop a severity index from claims data. Here is a sample claims data for 10 cases for a particular hospital. For time's sake, this data is a mere representation of actual claims data, which are usually comprised of hundreds of data entries to analyze. In any case, we will be using the given data to analyze the severity index of multiple diagnoses, such as myocardial infarctions, congestive heart failure, diabetes, hypertension, ACL surgery, and alcohol use. The first step in developing severity indexes is to separate the interacting diagnosis apart from the non-interacting diagnosis so that the analysis can be conducted separately. Of the cases given, the ACL surgery diagnosis is the only case in which we must take out at this time to get an accurate severity index for MI, CHF, diabetes, and hypertension. Next, here we have detailed the previous data into indicator variables of MI, CHF, diabetes, hypertension, and alcohol use, inserting a formula that calculates the value of each cell pertinent to the variable at hand. The subsequent numerical values have been found accordingly, indicating that the particular diagnosis is or isn't present per each case analyzed here. The next step is to conduct a regression data analysis as shown here. To calculate standardized scores, we take the value of the score and subtract it from the minimum, then divide it by the maximum minus the minimum for all the scores. As you can see, once calculated, the score for CHF is at the maximum with a value of 1, and hypertension is at the minimum score of 0. MI score is 0.75, alcohol use is at 0.25, and diabetes is at 0.208. Now that we have calculated the severity scores for each variable, we must calculate the overall severity of multiple diagnoses. This is calculated by a formula that takes 1 minus the value multiplied by the severity times every variable and can be seen below the chart as to how the overall severity was calculated for each of the cases. We now see that the overall severity is 1, caused by CHF score of 1, meaning that this case results with the most sickest patients in comparison of the various variables analyzed. And for every case where CHF is present, the number 1 results, indicating this finding. Respectively, where only MI is present, a score of 0.75 results in the overall severity of the case. Also, in combination of MI and alcohol use, 0.8125 is calculated as the next severe case, but still less than any CHF diagnosis shown here. The final step in this process is to plot the length of stay against severity as shown here. Although there are few cases in this project, we have added a trend line to see if we can make a connection of the given data. Here, we find that there is a clear relationship of severity and length of stay despite altering severe cases for CHF. By developing a severity index, accurate measurement of severe illnesses can help administrators understand the quality of care their organization is providing. Because changes in outcomes of patients are first attributed to severity of illness before intervention, it's important to have accurate measures of severity in place to see whether a patient who entered the hospital with a less severe illness and resulted in a serious adverse event could lead us to question the type of quality of care and not the initial illness that the patient had come in with. Finally, this method is a simple way to extract data from the claims department and produce more accurate measures of illness severity, which could lead to greater comparative studies in the future.